All right, hello students. Today we're moving on to lesson 9, writing addition, subtraction, expressions. Today we're going to kind of talk about how we take sentences or phrases and convert them into an addition or subtraction expression. So here, let's go ahead and go with example 1. I create a bar diagram that shows 3 plus 5. So as you know, I have some boxes here. I'm going to copy, I'm going to paste a few of them. So I'm going to kind of show it as a bar graph or as a bar diagram. Not really a bar graph, it's more of a bar diagram. So we're going to show 3, and of course here's 3 units. Um, so of course these 3 right here, these 3 boxes of course represent 3. And then of course I do it again because I want to add 5 to it. So I copy and I paste 1, 2, 3, 4, 5. I go ahead and produce 5 more units. Of course I'm going to try to get as close as possible. We'll save some time. They might not connect. Yours should be connecting. And of course we have 2 more to go. And then there you go. All right, so then we go ahead and grab our pen. This is showing 5 units here. So of course, how do we show this? Of course, we're adding these together. This is an addition problem. We started with 3 here, we added 5 here, and of course we have 8 altogether. Well, the next question is, how would it look if you were asked to show 5 plus 3? So we're going to show the same model now, but now we're going to use a model again. And now we're going to show 5 plus 3. So now we need to start off with 5 boxes. So 1, 2, 3, 4, and 5. So now we're going to start off with 5. And now we're going to add 3 to that. So we're going to add 3 more units um, to that diagram. So copy 1, 2, 3. So let's go ahead and draw, or you can draw as I place these 5 boxes in here. All right, and of course that is adding 3 to it. So of course there's your other expression. So using a model, here's our model boxes. Here are our model boxes, 3 units here plus 5, 5 units here plus 3. And it says, are these two expressions equivalent? Well, yeah, of course they are. They both equal 8. We kind of talked about that in another lesson. This is called the commutative property of addition. So the question is, are these expressions equivalent or equal? Equivalent is a fancy word for saying equal. And the answer is yes. And we can show that both, what was the first one? 3 plus 5 and 5 plus 3 equal 8. So no matter how you kind of write it, either we have 8 boxes here, we have 8 boxes here, it doesn't matter kind of how we add them together. All right, so let's go move on to example number 2. So now it says here, how can we show a number? So this is called a variable, simply a number we don't know, increased by 2. Well, this is how we show it. We're going to take a box again. So this is a number. This is really a number we don't know. And some people like to make it larger than others. It really doesn't matter. Um, but this is simply a number that we do not know. This is what we can call a variable. So we can really assign any letter to it, but we're going to go ahead and call this A for right now. This can represent anything. It can represent 2, 3, 10, 20. It really can represent any number out there. So now if I'm going to add 2 units to it, I'm going to copy and I'm going to paste twice. So now I have 2 here and I have 2 here. So now we go ahead and we're going to add 2 units to it. So this is actually a representation of 2. This box here, we don't know what it is, so we're going to add a plus 2. So that's a kind of a basic representation. This is, can you prove this using a model? Well, we just did that. And so another way we can simply write this, of course, is a plus 2. This is our model that we have. But remember, we also can write it the other way. We also can write it 2 plus a. And of course, we can still use a model to represent that as well. We can write it backwards. That is perfectly fine. So let's go ahead and make the model of that as well. So of course we have this. We're going to go copy, paste, paste. So here we go. First we have 2. And like I said, I like to kind of draw this kind of showing this is what represents 2 here. Okay, like I said, not perfectly lined up, but I'm just trying to save some time. And then, of course, here's my a. So 2 plus, and then, of course, a. All right, so there you go. So as you can see, kind of both ways. It doesn't matter, very similar to what we did above. So I kind of answered this question up here already, but of course, these are the two different ways we can write it. All right, if you go and look down now, example number 3, just write an expression. So now notice it doesn't say a model. We're just going to simply write an expression to show that the sum, so remember sum, we've talked about this several times. The sum is the answer to addition problem. So we're going to write the sum of m and k. So m plus sign k. Well, that's one way we can write it. You also could, of course, write it backwards or the other way. Since we're talking about addition, it really doesn't matter how you write it. They both mean the same thing. It doesn't matter if you add, like I said, 3 plus 5 or 5 plus 3. We simply can write it either way. And of course, if we look at the last part here, I'll draw a text box here. Which property can be used to use in examples 1 through 3 to show that both expressions are equivalent or both expressions are equal? So what does this mean when we're taking we're taking the numbers or the terms and switching them around? Of course, this is called the commutative property of addition. And we talked about that in one of the other sections. This is something that we have to be able to recognize. This is called the commutative property of addition. It doesn't matter how you add two things together. It always doesn't come out to the same answer. All right, so you can stop the video and go ahead and move on. All right, hello students. Now we're going to move on to example 4. Now we're going to kind of talk about addition in the first one. We're going to talk about subtraction here. Here it says, how can you show 10 minus 6? It says, draw a diagram. Well, I've already kind of set up the diagram for us to kind of save us some time. So if you want to hit pause and go and create the same diagram here on your paper, then we're going to go ahead and kind of talk about what this means. It says, draw a bar diagram to model this expression. Well, of course, the first number is what we start with. We start with 10. So there's 10 boxes here. Excuse me. And of course, we can show this. All these, of course, represent 10. Now it says minus 6. So 6 of these boxes have to go away. So instead of kind of erasing them, I'm going to go ahead and just kind of draw a line through 1, 2, 3, 4. There's that 5 and 6. So of course these 6 boxes are being taken away. So we subtracted 6 boxes. And so of course our answer is 1, 2, 3, 4. The 4 boxes that are left over. So here it says write an expression to represent this model. Well, of course, when we're subtracting, we first start with the number we're starting with. We're starting with 10. And then we subtract or take away how many we subtracted or took away from it. We got rid of, or we crossed out, in this case, 6. I didn't want to delete. I want to kind of show it. And so this is the expression of this model. We started with 10 units. We got rid of 6 of them. And of course, we have 4 left over. So that comes down to the next question. This is an interesting question. Because with addition, it doesn't matter how we add. 3 plus 5 is 8, and 5 plus 3 is 8. But does it matter how we subtract? And the answer is yes. We can't. Could we also use the 6 minus 10? The answer is no. These are not the same thing. This would be, I started with 6 boxes, so I'd almost be kind of stopping here, and I'd be taking away 10. Well, it's only 1, 2, 3, 4. Well, let's go ahead and kind of draw that or kind of show that as a diagram. So once again, I'm going to start with 6 boxes here. And the question is, I need to take away 10 of them. Well, if we kind of think about this, this is 6, right? If I started taking away 10, so if I went 1, 2, 3, 4, 5, 6, I don't have any more. I would need, if I keep going over here, 7, 8, 9, 10, I would need 4 more boxes. I need 4 more. So this doesn't work. This is not the same thing. This, I have 4 boxes here. This one, I need 4 more boxes to subtract. So these are not the same diagrams. So they don't work out the same like addition does. So the question is, could we also use 6 minus 10? And the answer is no. If we kind of expand upon that a little bit more. If we started, so kind of what we said, we started with 6 and tried take away or take 10 away, what would happen? We would need more boxes, or or simply the model does not match. The model, or models, excuse me, because we're talking about more than one, would not match. For it to look the same, the models have to look the same, just like our addition one did. This one would not. This one has 10 boxes and 4 boxes left over. This one had 6 boxes and we need 4 more. So that's not the same thing. All right, so a subtraction and addition cannot be written kind of forward and backwards. They can't be written. Only addition can have the commutative property. All right, so we go ahead and kind of move on. We look at number 5. Now we'll kind of discuss kind of another interesting part with subtraction. It says, how can we write the expression to show 3 less than a number? So this is actually starting off with a number, and we're going to take 3 away from it. So once again, it says, start by drawing a diagram to model the situation. And it says, are we taking away are we taking away from the 3 or the unknown? So which one are we really taking away from? Well, 3 is being taken away or being taken away from the unknown. So once, oh, oops, I didn't grab the text part. So what are we taking away from? We are taking away from the unknown, or the second number. Taking away from the unknown, or the variable, I guess would be a better way, another way of saying it. Unknown number, and this of course is called a variable. So if we kind of look at this, and this I'm just going to simply draw. So we're going to go ahead and kind of write a box here. This represents the unknown. We're going to call this n. So we're going to take 3 away from this. So you have to have something to take 3 away from it. So this is the n. This is kind of the unknown we don't know. And so we're going to take 3 away from it. Well, I'm just going to kind of draw a little box. Just going to take 3 little boxes away from it. We really don't know what n represents. And of course, here are our 3 boxes. So just simply we're going to take 3 away from it. Whatever n represents, and that's when I didn't go on forever, because I'm not sure how many boxes should be in n, but I'm going to take 3 away from it. So if you notice kind of that this first number actually came second in the equation, because what we're going to do on our second part is says, okay, what expression would be represented by the model? Well, the model represent is I have a number, and this is kind of what's important about this less than situation, and I'm going to take 3 away from it. This doesn't say I have 3 and I'm going to take something away. This says 3 less than the number. Well, the number is, in this case, is n. When it says a number, it just simply means a variable. And I'm taking 3 away from it, so I'm doing that subtraction. Okay, so very important. I'm going to let you know that right now. The majority of you will still not listen to this, but this is one of the most important things that people mess up on. So please make sure you take your time and kind of look at that. All right, actually, we're going to go ahead and stop right there. We're going to stop this video right there. We're going to move on to the next video with the other situations and kind of go over some more examples. All right, hello students. Now we're going to move on to where we kind of have multiple situations and we kind of have groupings coming on. So let's go ahead and look at example number 6. It says, how would you write the expression to show the number c, so once again here we're going to start just kind of using variables, being subtracted from the sum of a and b. It says, we'll first start by writing the expression of sum a and b. All right, now this is kind of an interesting situation because you have a subtraction word here, but then you have the answer to an addition word here. Now this is something that kind of pops up every now and then. This is why we have to understand the answer words. Like the word sum is the answer to an addition problem. And whenever we have this situation, it means we have to do this first. It's like these are being put in parentheses. So what it says here, it says start by writing the expression the sum of a and b. So once again, whenever you see this word sum of a and b or difference or product, that means we have to actually do this situation. we have to take care of the sum of A and B first. So it's like putting them in parentheses whenever we see that kind of answer word come up. So we have to find, now of course you could write it that way. Of course we also could write it this way. Either one really would work because it's an addition problem. Well, the next part, it says, um, and here we go again, C is being subtracted from this answer. So kind of another situation. C is being subtracted from. So it means I have to do this situation first. I have to add A and B, and then I can subtract C from it. So kind of finalize this up. It says now show C being subtracted from the sum. So we really don't have to put this in parentheses because with addition and subtraction, we have to go left to right. But I like to put it in parentheses because this word sum really means to. If it says like C minus the sum of A and B, well, I still have to add. And C then is kind of, and this answer is being subtracted from C. But since it says C being subtracted from, keyword there, that means I have to subtract C from this answer. And so you notice it came first in the phrase, but it came last in the expression. And that makes a difference. You have to look at how it's being worded or how it's being presented to you. So whenever you see this subtracted from, less than, you need to actually pull it to the back of the expression. So just kind of another thing that, once again, very, very important. Most people won't want to listen to this, but very, very important that this subtracted from means it has to go to the back of the equation or expression, excuse me. All right, so now let's just go over a few kind of examples. So I skipped, as you can see, 1 through 3 on the exercises. Those are pretty straightforward, easy. I thought pretty easy. So I want to go over kind of some more of the complicated ones that you might see and kind of discuss them together. So number 4, it says write an expression and model showing 3 less than P. Now, once again, I kind of chose this one because, once again, 3 less than P. So what means I start with P, I start with a number I don't know, and I have to subtract 3 from it. Okay, it's not 3 minus P, that's incorrect. So if you thought of this, and I'm writing this down to show you, this right here is incorrect. A lot of people will write that. That is wrong. Now we have to show a model. Well, our model, remember, starts with P, starts with the variable. In this case, anyway, starts with the variable. And we need to take 3 units from it. I like to cut it up into 3. 1, 2, and 3, and kind of show that they're being subtracted. You also could just simply draw a box in it and write 3, and that would work as well because we don't know how many units are in P. We don't know what P represents. So now if we look at a different one, this is kind of taking the same problem as 4. That's kind of why I like this one or put these together, but it says it differently, and this is what's important. It says the expression shows the difference. So here you go, the answer to a subtraction problem of 3 and P. Well, since it just simply says that they are being subtracted, 3 and P, well, that means you just simply take them in the order in which they appear. Nothing says that P at 3 is being taken away from P, like this one, or even the one before it, in the subtracted from. So there you go. It doesn't say to make a model, so we don't need to draw a model. That just simply is the answer. There's our expression. So your answers in your kind of activity today will look like this. They're not going to be just simply one-word answers. They're going to look like this, in this kind of manner. All right, let's go and look in kind of two more assignments, or 2 more problems, excuse me. It says, write an expression to show 4 less than, here we go. See, I like to, whenever I see that word less than or the word than, means that I'm going to take this and I'm going to move it to the back of kind of the equation or the back of the expression. And it says the sum of G and 5. So I'm going to show this first. So once again, the word sum means I need to add. So G plus 5. I just like to put these in. Now you don't have to, but I like to put these in the parentheses to kind of get in the habit. And whenever I see the word sum, they have to go together. You can't separate them. And then of course the less than 4. Let's go ahead and pull out our red and kind of write it in red. Less than 4 or subtracted 4. Okay. Once again, the parentheses don't have to be there, but whenever I see kind of the answer to an addition problem or subtraction problem, multiplication, division, I like to put them in parentheses because it means you have to do that first before you do the next step. And of course, parentheses mean that. All right, so if we kind of look at the other one, Now, once again, I put these together because of the wording. The less than means it goes to the back. If we look at this one, it says write the expression to show 4 decreased by. So 4 is our number, and it's being decreased by the answer to um, the sum here. So this is where parentheses are absolutely important. So once again, we have the sum of, we have to put this in parentheses, of g plus 5 because 4 is being decreased by it. So since 4 is being decreased by it, let's go and put that in blue. This is being subtracted. That is decreased by the sum of. So 4 is actually being subtracted from, or sorry, being decreased, or excuse me, by the sum of g and 5. So remember, the word less than means it goes to the back. The one before it, sorry, not the one before it, but this one, example 6, subtracted from means it goes to the back. But if all it says is decreased by, well, 4 is being decreased by this next part. And that's simply kind of how it's read. And so there you go. That would be our answer. It'd be 4 minus g plus 5. Of course, if you switch a g and 5 around, it doesn't matter because it's addition. All right, so once again, subtraction absolutely matters where it's being located, and the wording is very, very important. So we have to be careful of what it says. Here it says 4 less than this answer. This one says that 4 is being decreased by that answer, and that makes a big difference. All right, so go ahead and stop the video and go and move on to your assignment for the day.